Okay, now we're going to go ahead and do 3.1 Part B. For Part B, we're going to be looking more in depth into slope. So we already know that slope represents rise over run. But we want to be able to do this without a graph. To do that, we're going to use the slope formula. The slope formula is going to be using y2 over y1, x2 over x1. So we're going to have to label points so we can find the slope. And that's what we're going to be doing in Part B. The next thing we're going to be doing is the slope of lines that are considered like the special type of lines. The first one is when you have a horizontal line. When you have a horizontal line, you're going to end up with a slope of 0. If you have a vertical line, then what you have here is a undefined slope. So we'll look at those special slopes of lines. So let's start with problem number 3. So here we're going to be finding the slope using points. So there is no graph. What is the slope of a line through -1 and 0 and 3, -2? So notice that I've already put the formula, the slope formula, which is y2 minus y1, x2 minus x1. So the way this works is we are given 2 points. This represents x, this represents y, this represents x, this represents y. What we're going to do is we're going to make this our point 1. And we'll make this point 2. So we'll make this point 1. So what we're going to do is we're going to call this not just x and y, we're going to call it x1, y1. Point 2, we're going to call that x2, y2. So the 2's represent point 2, the 1's represent point 1. That way we can tell the difference. Now we're going to go ahead and substitute the values into the slope formula. So for this one, if I follow the formula, our y2, we have to identify that from the 4 points. So our y2 is going to be the y for point 2, which is a -2. So I will place a -2. Then I have to apply the negative. This is very important. A lot of students make mistake because they are going to get confused with this negative. You must first apply the negative. So we're going to go ahead and apply the negative. So it's -2 minus whatever y1 is. Okay, so I'm going to put a parenthesis there so I can tell that I'm going to plug in our y1. So this is going to be y2, so I'll put that in parentheses, minus our next parenthesis, which is our value of y1, which is 0. For x2, x2 is going to be the value of 3. So we're going to go ahead and subtract 3 because that's our x2. And we're going to subtract that by the value of x1. x1 is a -1. So now we want to simplify this. So our slope is going to equal to -2, so I'm going to get rid of the parentheses, minus 0, divided by, get rid of this parentheses and put a 3, and then you have a negative times a negative. When you have a negative and a negative, that turns into a positive. So that's going to change to a positive. So I'm just showing you the visual there. So this becomes a +1. Simplifying it further, you're going to end up with -2 minus 0 is a -2. A 3 plus 1 is going to give us 4. And we can even simplify this even further. There's a negative on the top and a positive on the bottom, so we'll put the negative in the middle. 2 over 4 can be reduced to 1/2. And there's our slope. So our slope is going to be -1/2. Let's go ahead and continue with the second problem underneath. What is the slope of a line through 1, 3, 4, negative 1? Again, you want to label each point as x1, y1, x2, y2. And then we're going to go ahead and use the slope formula to find the slope. For y2, we're going to use negative 1 because this point is going to represent point 2. So we will place negative 1, and let's put this in the parentheses, and we're going to subtract that by y1. y1 is going to be 3 because this is going to represent 0.1. So we're going to put a parentheses and put the value of y1 of 3. So you can think of this as putting parentheses around the y1 and the y2. The reason I do that is because I don't want to make a mistake of this negative and forgetting about it or making some kind of mistake like that. So I'll just put a parentheses around y2 and y1. I'm going to do the same thing for x2 and x1. For x2, I am going to use 4 minus the value of x1, which is going to be a 1. I'm going to simplify this further. This is going to be negative 1, so I'm going to get rid of the parentheses, and I'm going to get rid of these parentheses because there's no change, so it's going to be negative 3. On the bottom, I have a 4, nothing changes there, minus this value, which is a 1. So simplify this even further. My slope is going to equal to negative 1 minus negative 3 is a negative 4, divided by negative 4 minus 1, which is a 3. Because there is a negative, I will put the negative in the center, and I'll leave it as 4/3. And that would be my slope. If you want to change that to a decimal, you can also do that, and you can say that this also could equal a slope of negative 1 point, in this case 3, so I'll put a line right here. Okay, 1 1/3. Alright, so that's example number 3. Let's go on to example 4. For example 4, we're going to use these special types of slopes, okay, which are the horizontal and the vertical lines. Under that situation, when you have a horizontal, which is a horizontal line like the one here in the graphic, the slope is going to be 0. When you have a vertical slope, that special slope is considered an undefined slope. So let's look at the examples on problem 6. What is the slope of the line? So notice that this slope is a horizontal slope. This slope should be 0. But we can also find the slope by using the slope formula, so we can verify it. So I'm going to go ahead and label this as x1, y1, x2, y2. So my slope formula is y2 minus y1, x2 minus x1. So I'm going to go ahead and substitute those values. For y2, I'm going to put a parentheses around that, is going to equal to 2. Minus the value of y1, which is going to be 2. x2 equals to 2 minus my x1, which is a negative 3. So 2 minus 2 is a 0. 2, and then I have a negative and a negative, which is really just 2 plus 3. So my final slope is going to be 0 over 5. 0 over 5, when you plug it in the calculator, you get a 0. So it verifies that a horizontal line has a 0 slope. Now for part B, we're looking at these 2 points. Same thing. I want to label the points. So I'll call this x1, y1, x2, y2. It never matters which point you choose to be 1 and 2. So slope is y2 minus y1, x2 minus x1. Let's substitute the values. For y2, it will be a -2 minus, again I put this in parentheses, the value of y1, which is a 1, all divided by the value of x2. x2 is a -2 minus the value of x1, which is a -2. If I simplify this, this stays as -2. This negative in the 1 in the inside becomes a -1 or -1. The -2 doesn't change. And then I have a negative which turns this into a positive, so this becomes +2. Simplifying this even further, you're going to end up with -3 over 0. When you plug this in the calculator, you're going to get an error because it is not possible to get a 0 underneath. It's undefined. So our answer is undefined. So it confirms that when you have a vertical line, you have an undefined slope. This is the last part of 3.1. Go ahead and summarize your notes and finish up the problems that now I've set up for these set of problems. Till then, bye.